Okay. So when we talk about the statistics, so first we must understand what is variables, right? What are the variables and what is variable all about? So it's kind of property that can any value can hold, right? If we are having any kind of data, of course this will be that kind of property and it's going to hold that kind of value there. So there are two kind of variable. First is quantitative, right? And the second variable we have is called qualitative. Qualitative, right? So this quantitative and this qualitative is based on some magical variables, and we have some different values for this, right? For example, we can perform numerical operations for these quantitative value, and for these numerical value we can go for some operations, right? We can subtract these values using mathematical option, right? We can go for the multiplication also, right? We can divide the values, etc., right? For these quantitative value we can go for the mathematical operation, whereas qualitative values are called somewhere categorical, and these categorical variables are represented by some derived categories, right? For example, we have some categories. Now let me give some example for these two different quantitative and qualitative, right? For quantitative we have number of students in class, right? For category we have, let's say, eye color. What is the color of my eye? This is the first example for my value, right? Second example is kind of square feet in a house, square feet of house, right? This is the kind of area of my house. This is quantitative, some quantitative value there. When we talk about gender, let's say male and female, so this would be the part of qualitative, right? When we are talking about age of any population, right? So this is quantity. But when we are talking about level of education, so this is something different for this categorical value. This is categorical value, right? So on the basis of quantitative value, we have divided these quantitative value into two parts, right? So first part is like something we have is called discrete value, right? Sub is first part of my quantitative value is discrete, and second part is called continuous. All right, what is discrete and what is continuous? Let's come again for the description part. The illustration part of discrete is, let's say we have whole number, right? For the whole number, let's say 2, 4, 6, 8, 10 and so on. So we have discrete value, no decimal point, certain interval points are there. So a numerical variable that infinite number of values, that contains infinite number of values, is called continuous, right? For example, the height of students inside the class is lying between 172.5 to 163.9, right, or 183.9. so this is the range of my height in my class. So you cannot say this is varying about this value. So some candidate may have 172.6, some candidate may have the height of 172.2, and we cannot have that definite value for these. This is the reason it is called continuous. We have data set in the continuous manner, but in the discrete we have as a whole number stepwise value. right? Now again, when you talk about variable measurement, what is the variable measurement here? So variable measurement are of different types. In the statistics, we have different type of variable measurements. First is called nominal, right? So what is the nominal value? So nominal is nothing but it's a kind of categorical value, right? It's kind of categorical value, categorical data, right? Let's say we have like software engineer, right? We have executive part, we have CEO inside the company, right? So this is kind of nominal value, right? Similarly, we can have some order there, right? Sometimes there are some order. So ordinal values are what? So ordinal values are based upon order of the data matters, but value doesn't, right? So what is the order here? Let's say, so suppose we have like senior citizen, right? Then we have adults in our society. Then we have toddlers, right? Then we have children in our society. So they are having some kind of hierarchy, and you can say they are acquiring some kind of order in our society, right? Third kind of measurement variable scale is called interval, right? So we we may we may encounter some interval value, and where we have order matters and value doesn't matter, but natural zero is not present, right? We can have some kind of interval there. Let's say 7,9, right? 10 to 12 age group, right? So this age group for class, let's say 10th, the candidate from class 10th will be of this age group. When we have 10 to 12, so this age group will be for class a 9, sorry, 11th, I would say, right? So there are some interval for the same. The second term is called ratio. So let me brief all these terms one by one, and we will use all these terms in upcoming Python hands-on questions. So something measured on a ratio scale and has some property is the interval value, right? So we may have that kind of ratio, right? For example, we have student, right? Then we have rank, right? So student, and we have marks, right? So there might be some respective value. Let's say I am having 100 marks, 96 and 57, then 85, and then I am having 44. So of course there would be some rank 1, 2, then 3, then 4, then 5. So this is kind of order data. We have order data here, and we have respective value for the same, right? So there here are some ratio or some practical value there, right? Now now the final we have is called, we will be next term we will be using there in our bar chart, in our statistic term, that will be called bar graph, right? So what is bar graph here? Let's say we have favorite cold drinks in our canteen, and these cold drinks are having different types, right? And this is kind of 10, 9, 8, 7, 6 till 2, 1. This is their frequency, right? Then we have, let me create this line over here. This is the first direction. Create this line here. Then I'm having this line over here. This is the horizontal line, right? So along the horizontal line, we are creating some bar chart for the same. For this, let me create this one is the first bar chart, right? For the another cold drink, I am having another type of bar chart frequency, right? For another kind of integer value, so I am having this frequency of my another cold drink, right? For another cold drink, I am having this kind of bar chart, right? So these are frequency for my different cold drink values. Let me have the final cold drink there, right? If you write down the names of these types, so this will be, let's say, Coca-Cola, right? So this will be Pepsi, for example. This will be Limca in your canteen. Number of Limca in your canteen is 6. Number of Pepsi in your canteen is, let's say, 5, right? Number of Coke in your canteen is, let's say, 2. And number of, let's say, Mirinda, we have number of 8 Mirinda in our canteen. And when we talk about the, let's say, this one is the Pepsi, Coke, and let's say this one is the Mazda. So we have 5, or let's say this is 5 and this is 4, right? So 5 Mazda in our canteen. So this is favorite category of my cold drink, and based on these category, this bar chart is showing, right? So this is called of histogram, right? Kind of bar graph for my values, right? So so when we talk about the next topic, similarly we have some histogram for the same. So what is histogram? Histogram is actually used for continuous data set, right? So for continuous data set, we have histogram. Let's say it is a graphical tool to summarize discrete or continuous data set. Let's say we have age group in my student. So this is the age group, and for this age group, we have, let's say, 10, 12, 14, 18, 29 till the, let's say, this is 43, this is 50, this is 51, and this is the batch of my age group in my class, right? So can we create the histogram for the same? Yes, we can create, and we can create the graph for this value, and this graph will be called histogram, and number of frequency we will be using here, right? So you can see this histogram will be like kind of this structure, right? So number of frequency will be shown there, and number of value will be represented there, right? So you can see this a kind of probability density function, and here we have to construct the histogram, and number of bins are showing over the x-axis. You can decrease or increase the number of bins. If data set is very start from the 0, so you can create that kind of bins over there, right? So this axis value is 0 here, right? Now, so relevant to this histogram value, we are having some arbitrary values. Let's say these arbitrary value are correlated with mean, right? So for mean value, we have something relevant to the value. Let's say this data set is 1, comma 1, 2, 2, 3, 3, 4, 5, 5, 6 and 10. So we have this kind of age group, and I need to calculate the mean value, or in other term I need to calculate the average value of these value. So what I'll do, I'll sum up all these value. Let's say this is the set of S. So I'll add sum of Si divide by number of items. So what I'll do, I'll write 1 plus 1 plus 2 plus 2 and so on till 6 plus 10 divide by how many numbers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Divide by 11. So this would be equal to something 132 divide by 11, or in simplify this is 12, right? So here you can see the mean of given data set is equal to 12 here, right? If you want to check other parameters, such as we have median value, right? So what is the median of my data set? So median can be calculated is divide by, first you need to sort the number if they are given in the random value, then you just find out the middle point, right? So if you check this entire 1 2 3 4 5 and then 1 2 3 4 5 here, so 5 data on the left hand side and 5 data on the right hand side, we have this 3 at the middle point. So median is nothing but the middle data when they are in the sorted order, right? So either they are in the descending order or they are in the ascending order, right? So finally we have this middle data is equal to 3 over here, right? The next point we are going to discuss is called me. So if it is like we have odd data set, so we will call it n, right? N divided by 2, right? Or n, nth middle point, right? So if this is n, if we have even data set, so this would be n1 plus n2 divide by 2, right? So middle two elements, and median will works well when we are going to convert entire addition part and entire division part, right? So the third point we are going to calculate is called mod. So what is mod here? So mod is nothing but most of the occurrence, right? We have data set of the most of the occurrence. Suppose we have 1, 1, 2, 6, 6, 6, 3. So we have most frequency of data set is 6 here. So our mod value for this value is 6, will be 6 here. So mod will be most frequency data set in our values, right? So we can see the another term we have here. So this term is called measure of dispersion, right? This is also used in the statistic part, and most of the times we are using this dispersion value, right? So this dispersion is including two things here. First one is called variance, which is most important, and the second part we will be using the standard deviation, right? So standard deviation and the variation, both these value will be written over here, right? So what are the formula for the same? So we have for the variance, we have formula for when we are talking about the population, which is the entire population value. So we have population value, and this would be equivalent to sigma square is equal to summation of I is equal to 1 number of terms in my value. In the numerator, there would be number of terms xi 1 by 1, the mean value or the average value of my terms, and divide by whole numbers, right? But when you talk about sample value, so for sample population, we will have variance formula which will be called slightly different. So this will be called S square is equal to sum of I is equal to 1 n xi minus x bar, which is the average part of my all the values divided by n minus 1, right? So this is the mean value of my sample set, and this is the all the values representing whole the values, right? Finally, we are going to calculate this last term. So this is called more last but not least. This is called standard deviation, right? So standard deviation is nothing. This is the square root of my variance, right? If you have already calculated the variance there, so you will check the standard deviation and you just get the square root for this value, right? So okay. So this time we are going to discuss the statistic value and how we are going to create all these value here, right? So first we are going to import basic numpy array, and we have first direction numpy as np, and second library we are going to import pandas as pd, right? So let me run both these code, and then we are going to copy the mean using based upon these two libraries, right? So how to calculate mean of my data set? Let's say I'm having this data set, and this data set is something around 12 comma 52 comma 68 comma 78, let's say 47, and then 96, then 22, then 36, and then 65, and then 44, then 9, right? So this random data set is scattered around the x-axis and y-axis, and let me get the print for the values, right? For this mean value, I'm going to calculate my np dot, let me inherit this mean value there. So this is going to calculate mean data. So this is around 48.1, right? If you want to sort this data set, so how to get this data dot sort? So we have this function for the same, and if I'll go to the home value and then parenthesis and then try to print this value, you will find print data dot sort. Oh, sorry. So let's say, let me store in some variable called x. Let's say this variable is p, and I'm going to store t is equal to this data dot sort, right? So why it's getting, oh sorry, this is data itself. Data is already sorted there, so I'm getting the sorted value for my random pieces. So here you can see the data can be sorted, but for calculating mean value you don't need sorted data set. So where do I need the sorted data set? I need to find out the next portion, which is called median here, right? So for this median, I'll be calculating some sorted value and all, right? So let's say we have already seen the median part is the mid part, right? So from this value, this is the first part, 5 values on the left hand side, 5 values on the right hand side, we have 47 in the middle. So let's go for the coding part. Are we getting the exact median part? Yes. So if we are getting the median part there, so what are the value for this, right? Now you have already seen the data set is already given here. NumPy import pandas over here, and then we have mean data set using the data random series are given over here, and then we are finally going to print this mean data set value, right? And finally we are getting 48.9, which is 48.09, and then we are going to sort this data set, data sort, and print data. You can print the entire data set from using data sort. Finally we are going to calculate this mean value using median value using this median function, and we have this np dot median, and within the median we are going to get the data set there, right? Can you see this is the 47. Left hand side we have 5 values, and on the right hand side we have 5 values there, right? If you want to calculate some other terms, let's say I want to calculate some mod value. So for these mod value we have different data set, right? Let's say I'm going to create this data set, and this data set will be pd dot series, and this will be kind of data, right? I just converted the entire list into the series format, right? And then try to use my mod data set, and this is mod colon space comma data dot mod value, right? So this is kind of mod value. You can see here we are getting all these values, right? Okay, so if we are creating the another values, let's say I'm getting this entire list over here, right? So this series is passed over here. This is kind of list, and just let me calculate the mod value for this one. So can you see this 52 is just repeating multiple times, because in the previous example, so when you are trying to print this data, so we have all the values single times. So this was the reason it was showing multiple values. But for this data set we are having only two repetition, and 52 sign two times. So this is showing mod value single value, right? Okay, so can we use another parameter? So yes, we can use the another parameters such as percentile, right? So for this percentile I am going to calculate the first percentile, and this percentile will be like print, and let's say this is the q1, and this q1 is a data dot, we have data dot percentile, and this percentile is around 0.25, right? So let me calculate this value. Okay, so do we have percentile? Oh sorry, it's not percentile, it's quantile value, QUANTILE, right? So 32.51 would be the first quartile, 25th percentile, right? So this will be Q1. If you want to calculate the second percentile, which is actually the second percentile or 50% value, right? So I'll calculate Q2, and you will find 49.5 for this entire series, pd dot series, right? So that would be the data set there, right? If you want to calculate the third 75th percentile, so I'll call it third percentile, and I'll name it Q3, and this value will be 0.75, and I'll get 65.75 for the third quartile, right? If you want to check the IQR value, which is actually something ranged there, right? So this IQR, for this IQR I need to calculate Q1 value. For this Q1 value I am going to calculate quantile, right? So this is the quantile value, and let's say pass 0.5, right? And for the third quartile I need Q3, For this, I'll change this 0.75 again. So now I store all these values. If you check the Q1 one more time, you will find same value 32.5. If you check for Q3, so you will find third value 65.75, which is 75 percentile, right? So what exactly I need? I need IQR value, which is actually Q3 minus Q1, and I need to print IQR. So this is the difference between or the range of entire value, right? So you can find out the maximum IQR. So maximum IQR, I'll calculate, or I'll calculate the minimum IQR, right? So this maximum IQR will be Q3 plus 1.5 times IQR range. Similarly, for this minimum IQR will be Q1 minus 1.5 IQR, right? For this maximum IQR, let me check this maximum IQR value. So beyond this 115.625, all the values will be called outliers, right? When I'll check this minimum IQR, so below this minimum IQR value minus 17.35, I'll get all the outliers value, right? Suppose we need to check some another aspects, another key terms, that is called range. So I'll call, so what is the maximum value in my data set? Let me copy it here. So if you copy this value here and write down here, so in this particular value, if you write, let's say data is equal to this one and data dot max, right? Okay, we don't have maximum value here. So mix of data, do we had that kind of function? Yes, we have 96 as the maximum value, right? So can we have minimum value, minimum of data, right? Yes, we have 9 as the minimum value of my entire list value, right? So I can subtract, can I subtract 96 minus 9? Yes, but not using this value, but I can take this value, that's maximum minus minimum, but C, and will store in the range variable and will call it maximum minus minimum, and try to print this as the range here, comma, range value, right? Can you see this range value is exactly 96 minus 9, right? So you can get the entire value from the same. If you want to check the variance using Python hands-on code, so for this we have this print value. With this print value we have the first part, that is the variance, and for this variance I'm having this np dot variance, and we have data, right? So for this 63.4097 would be the variance for my data set. We have already seen the respective formula for the variance, and this will be the variance value for my entire without the biasing part. Now the second part, or the next issue we are going to discuss, is standard deviation. And for standard deviation we have direct formula which is called print, and for this print we have code value, codes. Let me copy this value here, and standard deviation would be np.std, and this std is kind of data value, and this is 25.13, right? So this 25.13 will be standard deviation, right? And we know SD, there should be minus 3 SD, comma, minus 2 SD, comma, minus SD, right? and on the right hand side we must have plus SD and plus 2 SD, 2 times SD and 3 times SD value on the right hand side, right? So beyond these value, all these value are in between my entire normal distribution. I'm accepting all these value in between these three terms ideally. So 25, so if you say 25 into multiplication 2 would be second step for my case, right? For the third step, this value multiplication this one. So till on the right hand side plus 75.38 and on the left hand side minus 75.38, I am accepting all these values. But beyond this value, let's say this is 96, this is outlier for me, right? 75. So any value below 96, I don't have any below 96. Okay, so can I sort the data set, right? So data dot sort, right, and try to print data. Yes, I don't have any value except this 96. So in my entire list value, 96 is the only outlier. This is my observation. Is this correct?